So in this particular video, we will be talking about the mirror equation. Now, as we have discussed earlier, let this be a spherical mirror, or this be a part of a spherical mirror where this is your principal axis. This is your principal axis. This is my pole P. This is my focus F, and this is my center of curvature. This is center of curvature. So now let's consider an object AB that is standing upright. This is the object AB. Now the rays that will come from here, we'll just look at the top ray. So if the top ray intersects at certain point, the intersection of the 2 points will give me the top point over here. So this ray travels parallel to the principal axis. This is principal axis. So this ray travels parallel to the principal axis, and after reflection, it passes through the focus. So this is what is happening. This line. So another line, this line will pass through the center of curvature. This passes through the center of curvature, and after reflection it moves back. So in a way we can understand that after reflection it strikes over here. So we can say that the 2 points meet over here. So we will have an object, that is an image. This is the object, this is the object. So right now we have an image. Say suppose this is B dash and A dash. So this is my image. Now if you notice, we have followed all the sign convention. That is a line or a ray that is passing parallel to the principal axis, after reflection passes through the focus. And we have used another knowledge that a ray, if it passes through the center of curvature, it will again be reflected back towards the center of curvature. So this is so far that we know. Now why? Because this is striking it perpendicularly. So perpendicular, what happens if you strike it? This is perpendicularly. In a straight mirror, if you strike this perpendicularly, you will have a reflection that is in the same direction. Similarly, if this is a circle, now from the center, if you draw a line and if you take a tangent at that point, you will always see that this is perpendicular. So that is the reason, if anything that is passing to the center of curvature will be perpendicular to this tangent, and so it will be reflected back. So that is the main concept. Now this is all the figure that we have. This is A dash, this is B dash. Now what is this? What is this length? This length is F. Let this length be F. Now what is the distance between these two, that is B and P? The distance between B and P, let this distance be, say, U. I am taking this distance BU. So this particular distance is U. That is the object distance. Object distance. Now let's talk about the image distance. Let us define the image distance as V. Let V be the image distance. Now if you look closely, what you will see that B dash upon A dash by PM. Let this point be M and let this point be N. This is N and this is M. This is C that we have already established. So now B dash A dash, this is B dash A dash upon PM. What is PM? This is PM. PM is equal to B dash F upon FP upon FP. B dash F upon FP. Now what you have to do is you have to take the similarity of triangles. We have to prove that this are a similar triangle so that sides ratio is proportional. So for that, look over here, this is B dash A dash. This is B dash A dash and this is B dash F. This is B dash F. So look at this triangle. Look at this triangle. If you look at this triangle and if you look at PM, now this is a very large mirror and the distance is very small. So you can consider this to be a straight line. You can consider this to be a straight line. So if this is a straight line, this will be your 90 degree. Similarly, this is also 90 degree. So this is 90 degree, this is 90 degree. And if you look over here, I'm extending this image. If you look over here, this is the image that is being formed. This is the image that is being formed. So this is M and this is P. So we have considered, because it's a very large mirror, so M and P is almost a straight line. So if this is 90 degree and this is 90 degree, you see that this particular angle is equal to this particular angle. That is angle F. Angle F, this is F, this is B dash and this is A dash. So angle B dash FA is equal to angle PFM. So if two corresponding angles is if two angles is equal to the other two angles of the triangle, then we know that the third angle will also be equal. So if all the angles are equal, then we know that they are similar triangles. If they are similar triangles, we have similar triangles. So we have established, now please consult the geometry part if you have a bit of confusion. So if we have established, if this is a similar triangle, we can say that the sides are proportional. So this side is proportional to this side. Then this side, that is this side, is proportional to this side, this tree, and this part is proportional to this part. So that is why we have this particular equation. So now further moving on, after similarity of triangle, what we can do is, or B dash A dash is equal to BA, which is equal to B dash F, and this is equal to FP. Now why is this so? Because since PM is equal to AB, PM is equal to AB. Now why is PM equals to AB? Look at this, this is AB, this line is AB, and if it's traveling here, this is a straight line, and we have said that this too is almost a straight line. This is almost a straight line. See, suppose for a very big mirror, if you're considering a very big mirror with a huge curvature, then what you see is, if you look over here, if you look over this particular length, this length and this length, and if you draw a straight line, this length is almost equal, So if the angle between them is very small, if the theta is very negligible, so this length and this length becomes equal. So therefore, PM is equal to AB. So this is what we have arrived so far. Now further moving on, again if you compare for the similarity of triangles between triangle A dash, this is triangle A dash, B dash and P, A dash, B dash and P, A dash, B dash and P, and triangle ABP and triangle ABP. If you compare these two triangles, I'm magnifying this over here, this triangle and this triangle. This is 90, this is 90 and this is 90. If you look at this triangle ABP, we are comparing triangle ABP. So what is A, B and P? So draw a line that is over here, A, B, P. So this is my A, B, P, and we are comparing this with triangle A dash, B dash, P dash, A dash, B dash, P dash. So this triangle and this triangle. Now if you look over here, this is 90 degree and this is 90 degree. And what we know is, if we are taking this angle, if you look at the angle of reflection, this angle should be equal to this angle. So this angle and this angle should be equal. So angle APB should be equal to angle A dash PB. This is angle, this is A dash BP. Now please look over here, this is P. We have wrote over here as this is P. So this is 90 degree and this is 90 degree, and this angle is equal. So this is as a whole, these are similar triangles. So if these triangles are similar, so straight away we can write, after establishing that triangle ABP is similar to triangle A dash B dash P, we can straight away write B dash A dash upon BA. Now please name this equation. Let this be equation 1, which is equal to B dash P upon BP. So this be equation 2. So now comparing 1 and 2, let's see what we can derive. We see that B dash F upon FP is equal to B dash P minus FP upon FP, which is equal to B dash P upon BP. Now what is, if you look, what is B dash P? B dash P, we had named B dash P as U, but see, this was our original diagram. This was the object A, B. This was our center of curvature and this was our focus. So a part after reflection had traveled over here, and this part after reflection had gone back. So this is my position of the image. This is A dash and this is B dash. So this part, this point is pole P, this is M. So what is B dash P? This was my V. This was my V. So B dash P will be V. But from where are we measuring this? We are measuring this from back side, that is from the negative direction. So this will be minus V. Now if you look at FP, what is FP? This is my focus F and this is my P. So what is this distance? Distance is opposite to the distance of the propagation of light. So this is also FP is also equal to minus F, that is focal length. F is nothing but your focal length, that is distance from the pole to the focus. And the last one, that is your BP. BP, that is from pole to here. What was the distance that we had established? It was U, therefore this is minus U. So now if you put this in your two equations, you have minus V plus F upon minus F is equal to minus V upon minus U. So this is what you have. What is FP? FP was this is FP actually. This is FP. So this should also be FP. So now if you look closely, what is FP? FP is a focus and FP minus of F. So this becomes plus. What is BP? This is minus V, this is this. So BP dash minus BP. This is the proper sign convention that we can use. So now after solving this, what you can see is, if you multiply this, minus V minus U, that is plus VU minus Fu is equal to minus plus Fv. So this is what we have arrived so far. So now, say suppose I divide all of this with my proper sign convention, that is 1 by F, 1 by V and 1 by U. If I divide this, what I will get is 1 by, if you take this to be your, divide this whole equation, say suppose this is equation 3, divide this whole equation by FUV. Divide this whole equation by F into U into V. You will have, if I divide this by FUV, I'll have this to be F minus, this is U. So I'll have minus F into U. So I'll have minus 1 by V is equal to 1 by U. So properly writing this, I'll have, if I take this over here, I'll have 1 by F is equal to 1 by U plus 1 by V, and this is my required mirrored equation. Now if you look at the two heights, this is H dash upon H. This is the height of the image upon height of the object. So what is this? H dash upon H is nothing but your B dash A upon BA, which is nothing but your, from the similarity of triangle, as if this is B dash P upon BP, which is given by, finally this part is given by, if you look over here, B dash P upon BP, that is magnification M. So M is actually equal to minus V upon U. This is minus V upon U. Now, how did we arrive at this particular conclusion? That is, if you look over here, one is H dash, one is H. One height is above, one height is below. So in a way, what you can see is minus, this is minus H by H equals to minus V by minus U. So this becomes, magnification becomes minus V upon U. This is minus V upon U. So magnification, when someone talks about magnification, it is always minus of V upon U. So this is a part of magnification, and this as a whole is our mirror formula.